Look up. Beyond our atmosphere orbiting Earth are human-made objects. Satellites, telescopes, and something else, the X-37B, America's robotic spaceplane. It launches like a rocket, orbits like a spacecraft, and lands like an airplane. But what it does in between for months or even years is a closely guarded secret. The X-37B is a puzzle in our own backyard, a testament to human ingenuity and secrecy. Is it for science or does it serve national security? The U.S. Space Force, its operator, remains silent, fueling speculation. Imagine a spacecraft that can stay in orbit for over 2 years, then glide back to Earth and land on a runway, ready to go again. This is the reality of the X-37B. Its missions are classified, its payloads unknown, its capabilities the subject of intense debate. It represents a frontier not just of technology, but of secrecy. As nations and private companies race to the stars, the X-37B reminds us that some of the greatest mysteries are right above our heads. Why does this unmanned vehicle capture our imagination? Because it embodies our quest for knowledge, while withholding it. It's a locked box orbiting Earth. We can see it launch, track its path, and witness its return. But the secrets it carries remain out of reach. The story of the X-37B is about our relationship with space, secrecy, and the unknown. It's a story still being written, one silent orbit at a time. The X-37B is not just a machine, it's a symbol of our curiosity and our caution. And as it circles above, it challenges us to keep asking, what's really happening up there? What is the X-37B? Let's break it down. It looks like a mini space shuttle, blunt nose, swept wings, but only 29 feet long. Its compact size allows it to launch inside rockets like the Falcon 9 or Atlas V. The heart of the X-37B is its payload bay, about the size of a pickup truck bed, perfect for experiments, satellites, or classified cargo. Once in orbit, the bay doors open, exposing its contents to space. It's not just a passive observer. It can deploy satellites, test sensors, or run long-term experiments. A solar array provides power for its extended missions. Unlike the shuttle, the X-37B is fully robotic. No crew, just pre-programmed or remote commands. This autonomy allows it to perform long, risky missions humans can't. Its landing is fully automated, gliding to a runway like a pilotless plane. Advanced thermal tiles protect it during fiery re-entry. The X-37B is a hybrid, part spacecraft, part aircraft, built for resilience and reusability. It's a showcase of cutting-edge engineering, designed to conquer both space and atmosphere. The X-37B's story began at NASA in 1999 as a testbed for future reusable spacecraft. Partnering with Boeing, NASA envisioned it as a civilian project for affordable spaceflight. But in 2004, the program shifted to DARPA, moving from open science to military secrecy. The focus changed from building a better space taxi to exploring military potential. Under DARPA, the X-37B matured and the Air Force took over, seeing its strategic value. The first orbital flight launched in 2010, vanishing into classified operations for 224 days. Its autonomous landing marked a new era in military space. Since then, at least 2 vehicles have flown progressively longer missions. Now under the Space Force, the X-37B is a critical national security asset. Its journey mirrors the blending of civilian and military interests in space. What began as a NASA blueprint is now an orbiting enigma. The X-37B's mystique comes from the secrecy around its missions. The Space Force shares only launch dates and vague statements, never specifics. This ambiguity is strategic. If adversaries don't know its capabilities, they can't counter them. Is it testing spy sensors, practicing satellite maneuvers, or deploying secret payloads? No one knows. Its missions have set endurance records, over 900 days in orbit. Occasionally, small, unclassified experiments are revealed, like deploying a student satellite or testing space-grown seeds. But these are just glimpses. The real story remains hidden. The X-37B is a silent sentinel, its true purpose a closely guarded secret. With so little official info, experts and amateurs speculate wildly. Many believe the X-37B is a next-gen reconnaissance platform, able to change orbits and test new spy tech. Others see it as an on-orbit garage, capable of repairing, retrieving, or even inspecting satellites. Some suggest it could test anti-satellite weapons, raising concerns about space warfare. Its maneuverability and reusability make it ideal for a range of secret missions. Most likely, it's a versatile testbed, trialing new materials, avionics, power systems, and sensors. By using one reusable platform, the US can rapidly advance its space tech. The X-37B's greatest asset may be the mystery itself. Its ambiguity keeps adversaries guessing and the public fascinated. In the end, its true mission is to test and to keep us wondering. To understand the X-37B, consider its context. It's not the first spaceplane. The space shuttle was, but it was big, crude, and costly. The X-37B is smaller, unmanned, and built for endurance and flexibility. Other nations are following suit. China's Shenlong spaceplane flies similar secretive missions. This signals a new era of space competition. Reusable spaceplanes are now a benchmark of major powers. Commercially, the spaceplane concept is thriving too. Aerospace's Dream Chaser, for example, will carry cargo and crew to space stations, landing gently on runways. The same technology serves military, scientific, and commercial goals. The X-37B is a new breed, bridging expendable capsules and grand shuttles. It proves that small, autonomous vehicles have a vital role in orbit. Its legacy is not just in missions, but in showing a sustainable, strategic way to operate in space. The X-37B paves the way for a family of winged vehicles to come. It's a glimpse of the future of spaceflight. What is the X-37B hiding? We don't know, and that's why it matters. It's more than hardware. It's a symbol of our era, technological achievement and global tension. The X-37B could change space operations, routine satellite repair, rapid response, dynamic missions. This flexibility is a paradigm shift, making space more like air operations, continuous and responsive. That's why it fascinates us. It's a real-life enigma, tracked by amateur astronomers and debated by experts. The global game of tracking the X-37B connects us to the cosmos in a new way. Ultimately, it compels us to look up and wonder. Space is not empty. It's an active, evolving domain critical to our future. As we push boundaries, we must ask, what are the rules for space? The X-37B offers no answers, just more questions. It continues its silent journey, leaving us to watch, question, and imagine what comes next.